A quadrilateral with two pairs of opposite sides parallel is a parallelogram. A parallelogram with all angles the same is a rectangle, and all the angles are right angles. A parallelogram with all sides the same length is a rhombus, and a parallelogram with all angles the same and all sides the same is a square. Well, here are some examples of parallelograms, and some of them have better names. There's a square, two rectangles, and a rhombus. But two of them don't have better names. We'll just call them parallelograms. Now we've taken a parallelogram and marked it out on a grid. And we can use the grid to see that the bottom side is 10 units long. And then we can use the grid to see that the top side is 10 units long. And it turns out that in parallelograms, the opposite sides are both parallel and the same length. Now we're going to use the grid to find the distance between the bottom side and the top side, and we can count that out. That's 6 units long. And then we can make a right triangle starting from that orange segment that was the distance between the bottom and the top, and then we trace along parts of the parallelogram to get our right triangle, which imagine we could cut out like it was on a piece of paper. And after we cut it out, we'd move it over, and you could see that if we could do that, it would fit nicely over on the right. But rearranged, we're looking at a rectangle, which is 6 units by 10 units. And of course, for a rectangle, that's 6 times 10, or 60 square units. Well, that bottom side is called the base, and the distance from the base to the opposite side is called the height. In this case, the base was 10 and the height was 6. And that's what we multiplied to get the area, 10 times 6. We multiplied the length of the base times the length of the height. And that brings us to the formula of the area of a parallelogram. The area is equal to b times h, where b is the length of the base and h is the length of the height. Well, this particular parallelogram is a rhombus because all 4 sides have the same length of 10 units. The perimeter of this rhombus is 40 units. 4 times 10. Each side was 10 units, and there were 4 sides. So the perimeter was 40 units, and the area was 60 square units. Now we've rearranged the sides. We still have 4 sides that are all 10 units long, but we've rearranged them on the grid so that all of the angles are right angles. So, of course, we have a square. We know that the area of the square would be 10 times 10. And you can also see by the dotted orange line that the distance between the bottom side and the top side is 10 units. So the height of a square is the same as the length of one of the sides. So the base times the height is 10 times 10. The same as our formula for a square, which said that the area of a square was a side times another side, which is also 10 times 10. And that's because our height is the same as the length of one of the sides. So the perimeter is still 40 units long, but the area of the square is 100 square units. Now we've rearranged again. We have 2 acute angles, 2 obtuse angles. The distance between the base and the top side is just 3 units long, so the height is 3. 10 times 3 is 30 square units, but the perimeter of this rhombus is still 40 units. Here's a parallelogram, which is neither a rhombus, rectangle, or a square. We can count using our grid that the base is 7 units long. And to get the distance from the top to the bottom, we need to extend the base. Think of it as a tabletop. And we need to know how far is the top side from the table. And we drop that dotted orange segment, and when we can use the grid to count it, I've done that. It's 17 units long. So the base times the height is 7 times 17, or 119 square units. But you might ask, how do you know which side is the base? Well, if we turn this parallelogram so that one of the long sides is on the bottom, then we can think of the long side as the base. But relative to the long side, when you go to the opposite side, the height is much shorter. So when we use one of the long sides as the base, the height is shorter than when we use one of the short sides as the base. Now we're going to use the grid to measure out this long side, and it looks like it's about 20 units. Well, 6 times 20 is 120 square units. But that's not exactly the same answer. We got 119 square units when we used the short side as the base. But on further examination, we can see that we rounded to get 20 units. So if we hadn't have rounded, the base times the height of the long side times the new height of 6 units would have been 119 square units. But rounding to 20 units long for the long side, we get an answer just a little bit different than our first answer. But we can see that the area of this parallelogram is somewhere around 119 or 120 square units. Well, not all parallelograms can be measured using whole numbers. And then the grid isn't very helpful. So someone's already measured this, but since we have a formula, we know that we can just take the base, 9.5, times the height, 4.3, to get that the area of this parallelogram is 40.85 square centimeters. And we can use what we know about parallelograms to get the perimeter. We have a 9.5 on the bottom, a 5.2 on the left. The top is the same as the bottom, another 9.5. The right side is the same as the left side, another 5.2. We add them all up, and the perimeter is 29.4 centimeters. A quadrilateral with two pairs of opposite sides parallel is a parallelogram. Any of the four sides of a parallelogram may be used as the base. The distance from the base to the opposite side is called the height. The formula for the area of a parallelogram is that the area is equal to b times h, where b is the length of the base and h is the length of the height.